This is the Year 8 Earth and Atmosphere Reverse the Classroom. Right, so all the information that's going to be taught about in lessons, right, is touched on in this video. So you've got a good idea about what's going to come up in the actual unit itself, so you'll be able to learn quicker. We're going to talk about layers of the Earth, igneous rock, sedimentary rock, metamorphic rock, a little bit about the atmosphere, a little about the atmosphere and carbon dioxide, and a little bit about greenhouse gases. And this all leads into kind of topics in Year 11, where you then talk about these, particularly the atmosphere, in a lot more detail. Right, so what we're talking about here now is the structure of the Earth. Now, if you think from the surface all the way to the centre of the Earth is 6,400 kilometres. Right, it kind of puts in perspective some of these other little bits. So the outer layer is called the crust, a bit like the skin on an apple, and that is 5 to 550 kilometres thick. Right, 5 kilometres to 6,400, big difference. The mantle is a molten rock layer. The outer core is molten iron, and the inner core is then a solid mass of iron, and it's solid because it is in so much pressure, right, due to the amount of weight that is on above it. Now, just a few little differences or sort of definitions. Magma is when you got the semi-liquid rock underground, right? So if I was going to drill down here 50 kilometers, right, and what I'd do is I'd hit molten rock. That is magma. So magma is the rock that is underneath the ground. Lava is when the molten rock actually hits the surface, right? It comes out of a volcano. Now, the size of crystals in rock is dependent on the time the rock takes to cool, right? So if a rock cools fast, the crystals are small. If the rock cools slower, the crystals are then bigger. Now, what I'm going to do now is I'm going to go through the different types of rock, starting off with sedimentary rock. Now, the properties of sedimentary rock, they are in layers. Okay, so sedimentary rock are in layers. And what they are made up of is they are made up of small grains. And what they are is they're kind of very weak, right? They're kind of a weak version of rock, right? And they can often be quite crumbly. And these are then the rocks that may well have fossils in them because they haven't been exposed to the ridiculously high temperatures and pressures of the others. Examples: sandstone, limestone, chalk. And if you think, if I got a lump of chalk, I could just write on the floor with it because it's dead crumbly. And I could probably do a similar sort with sandstone and limestone, but not quite as effectively. Metamorphic. Metamorphic is made up of crystals. Okay, so it has got crystals. It is denser and harder than sedimentary rock, but it also shows distortions, right? Which kind of means it's been under pressure. All right, what it's been done, it's kind of been moved around a little bit. And the way that metamorphic rock is made, right, it is made by extreme pressures and extreme temperatures underneath the surface. Examples: marble and slate. Igneous rock has crystals again, right, but what the crystals are this time is they are kind of interlocking. And they are disorderly, so they're kind of all over the place, disorderly. And then I talked earlier about the size of the crystals. So big crystals is when it cools down slowly, small crystals is when it cools down fast. And igneous rock will definitely not have any fossils because they've been exposed to very, very high temperatures. Igneous rocks are formed underneath the ground from the magma. What it is, it's when the magma cools and solidifies. So it's the magma that comes out. When that magma comes out and turns into lava, then what you've got then is you've got your igneous rocks. These are then examples. We've got basalt. No, that's pumice. And we've got basalt. Now, gases. This is then just a little bit of introduction about the gases. In the room you're sat in at the moment, you've probably got about 78% nitrogen. about 20.9% oxygen, and then you can see then the percentages of all the other gases that you're then breathing in are relatively low. That is then the composition of the gases on Earth today, and that was very, very, very different millions of years ago. Now, the carbon cycle. Now, I'm not going to go through the carbon cycle. I'm not going to sit here and talk about each individual little strand of it, right? But what I am going to do is I'm just going to kind of give you a little bit of a tip on how to learn it, because you are going to have to learn it and you are going to have to learn some words. Personally, what I would do is I'd start with animal respiration. So I'm just going to put AR in the middle, which is animal respiration. Then what I want you to do is I want you to think about the arrows that are then going off from animal respiration. So we've got an arrow going that way, right, which is dead organisms and waste products. We've got another one that kind of goes up there from a tree next to it, which is then your plant respiration. And you've got an arrow there showing the respiration where the CO2 is then going up into the atmosphere. So that's CO2. Then you've got a plant, which is then giving out CO2. Then, if you look at it again, what you've then got is you've got a circle that goes around the outside, which is called the carbon cycle, which is this. Then what you need to do is you need to think about what is happening at each of the individual stages. So then, once you've kind of worked out that animal respiration goes off, plant respiration goes off, dead organisms or waste products are producing carbon dioxide, then learn the circle that then goes around the outside. And once you've learned the circle that then goes around the outside, then start adding in the other arrows that are then involved in the cycle itself. Greenhouse gases is in the news loads. There's two main greenhouse gases. We've got carbon dioxide, which is produced by us, where we're burning things like fossil fuels and deforestation. We've got methane, right, which is a greenhouse gas that's produced by livestock, so cows, landfills, and it's also, dead weirdly, is rice paddy fields. For some reason, rice gives off large amounts of methane. Formula for methane, CH4, carbon and 4 hydrogens. This greenhouse gases, what it does is it causes climate change, which is then where the climate in every single place around the world, it's kind of getting more extreme weathers and the weather patterns are changing. Now, the greenhouse effect itself. So what we've got around Earth, there is a kind of a blanket that is made of carbon dioxide and methane. They're the two greenhouse gases. And normally what happens is, what colour should I do? I'll do it green. Normally what happens is sunlight shines in, hits Earth, and then it turns into kind of heat energy that can then rise and it comes out. But as we make this carbon dioxide layer and methane layer thicker, less of that heat can then escape Earth. And so what happens is then, rather than that heat escaping, the heat stays in. And if the heat stays in, the temperature of the Earth increases. So really, I've put on here then a summary of it is the greenhouse effect is the trapping of the sun's warmth in the atmosphere. Recycling glass, right? So we've got this diagram here, it's a famous diagram, isn't it? Recycle, reuse, recycle, reduce, reuse. Recycle, reduce, reuse. Now, the main one that we're going to talk about in this is recycling of glass. Right, so this diagram here shows that. Stage one is you get your bottles, put them to a collection point, right, and they get transported. Stage two is they're cleaned, right, and then they are kind of split into clear, green and brown. But often at a recycling point, they'll have different holes in the collecting things that have got clear, green and brown glass. They are then recycled. Then what happens is, or sort of organised, then what happens is they go into a furnace and they're melted, put into a mould, and then they're then sent back to the customer supermarket as recycled glass. Now, your 5 questions. These then need to be written down in your exercise book. What are the 2 main greenhouse gases? 2 words. What are the 3 properties of sedimentary rocks? Kind of 3 phrases. Give 2 examples of igneous rock. How do I make bigger crystals in rock? And what are the 4 layers of earth? Now, there's a lot of information, right, that then you need to be able to recite back to me. A big thing is the difference between the different types of rocks. And if you don't get it, right, go back through the video, Google it, right, and have a look at where sedimentary, igneous and metamorphic rocks are made, how they're made, before you start going into any lessons.